Hello and welcome to the Module 3, Asynchronous Examples and Application within NLMAH Teacher Training course in Inactive Mathematics. In this presentation, we will explain how to create an inactive asynchronous example and corresponding materials. Asynchronous learning is a general term used to describe forms of education, instruction, and learning that do not occur in the same place or at the same time. Asynchronous learning allows students to learn on their own schedule and complete the activities at any time within the specific period. Asynchronous classes may include short videos that teach concepts that students can watch over and over again as needed. How to prepare an asynchronous activity? After designing the activity, the NLMAH template for the activity should be filled. The template contains all the relevant information for teachers for performing the activity. As mentioned earlier, in asynchronous learning, students perform the activity on their own, without the presence of a teacher. For this reason, the exercise for students must be prepared and should contain detailed explanations of the activity. They should also contain hints to guide students to correct solution. In this presentation, one example for asynchronous learning will be presented. The name of the activity is water activity. The aim of the activity is to introduce the concept of linear function and its properties. Students conduct an experiment in which they add, pour out water from a jar, and they note down the results. Using the tabular and the graphical presentation of the results, they conclude about a linear function and its properties. A relationship between the values of the coefficients of a linear function and its graph is examined. Moreover, the effect of the value of the coefficient of the independent variable on the property of increasing, decreasing is examined. Purpose of the task is introduction to linear function. Learning outcomes for the water activity are as follows. After performing the activity, students should be able to recognize linear dependence in problem solving, write it down in the form of a function, and apply it in the analysis of the problem. Use different representations of a linear function, analyze the problem using the graph of a function, calculate values of a linear function, draw its graph, and interpret its coefficients. Students' prior knowledge are proportions and linear dependence. Expected time for the activity. Expected time for students to perform the activity is 90 minutes. The material needed for conducting the experiment is water, a cylindrical jar with minimum volume 6 deciliters, a measure cup, but students can also use a weighing scale, and it should be emphasized that for water holds the equality that 1 gram is equal to 1 milliliter. A millimeter paper, a pen, and a ruler. The activity is divided into 4 parts. In the first part, students conduct an experiment in a way that they add water to a jar according to the instructions and note down the results. The results are then presented using a table and a graph. It should be pointed out that student solutions may differ because of the different size of the jar they are using. And using the tabular and the graphical presentation of the results, students notice a linear dependence between the total amount of water in the jar and the total water level in the jar. The second part is the introduction of the notion of linear function. In this part, the definition of linear function is given. In the third part, The obtained results are written in terms of a linear function. A relation between the values of the coefficients of a linear function and its graph is examined. More precisely, students conclude about the connection of the coefficient of the independent variable and the position of points in the coordinate plane. In the last part of the activity, students conduct another experiment in a way that they pour out water from a jar. They present the results using a table and a graph. The aim is to examine the effect of the value of the coefficient of the independent variable on the property of increasing decreasing. Observing graphs of linear functions, students conclude that a linear function is increasing if the coefficient a, coefficient of independent variable, is positive, and that a linear function is decreasing if the coefficient a is negative. Exercise for students and solution plan are written in separated documents. Remarks include all the other relevant information for teacher. For example, some difficulties that can occur while performing the activity. In water activity, an example of difficulty that can occur is that a jar has a round bottom. But this can be solved in such way that water can be poured in until the water level is above the round part. This water level can then be taken as the starting level. In this presentation, we have presented water activity as an asynchronous example for inactive learning. Documents that correspond to this activity are available at NLMA Learning platform.